the informal approach of finding limits, right? So everybody is clear about the understanding of limits, right? If you are not, there is one more opportunity coming up when we are actually doing the chapter with you. Okay? So if you could just recall what we did last class, it would be beneficial for us to understand the application, that is what we are going to do today in form of differentiation. Okay? So anybody can tell me what do you mean when I say limit of a function as x tends to a is L? Yes, brother.
So basically that means that as you approach closer and closer to L, as x goes closer and closer to a, the value of the function will approach L. It doesn't have to actually get to L at a. It becomes more accurate. But the limit of
okay. So basically, just to quickly recap, limits. When I say limit of a function f of x as x tends to a is L, it means the value of the function is approaching, or it may achieve also, the value L when x is trying to go towards a. Now it can go towards a from two sides of a. What we learnt as was the left hand limit and the right hand limit. Correct? So the limit of a function is basically the value that the function achieves from the left side of a, and it has to be equal to the value of the function from right side of a. Both of them should be equal, and that value is called the limit. Next, what did we learn? We learned the methods to evaluate limit. Method of factorization was one of them. First, method of substitution. Correct? And I told you it is not going to be the first method that is going to be asked to you, but it is used in the last step of all the problems. Next was the method of factorization. Method of rationalization. Then there were some standard limits. What were they? Algebraic standard limit, trigonometric standard limit.
There were a couple of results that we had to learn.
Yes.
Expansions.
Yes, we had learned expansions. Then we had learned exponential and logarithmic limits. Right? This was what we had learned. So today we are going to start our class with the application of this chapter. How do we actually use it? And today's class is even important than the previous class. So those who have missed out, or for those who are attending the class for the first time today, please be very, very attentive, because whatever we are going to learn now, that is going to be of extreme help to you. Not only in maths, but also in physics. Okay. So today we are going to learn a very important process in maths called the process of differentiation of functions. Okay. Now differentiation is a process out of which we get an answer which is called the derivative. Okay. So derivative is a result obtained through which procedure? Differentiation. Like sublimation leads to a residue which is called the sublimate, right? Whatever you call it, correct? So from differentiation we are going to obtain something called the derivative. What is derivative? And how it is, what are the properties of derivative? What is the geometrical meaning of it, graphical meaning of it? Everything will be understanding in today's class, right? Now, do you recall that in the beginning of the limits class, I had asked a question to you that you are traveling from Bangalore to Mysore, correct? And I asked you that when you are traveling from Bangalore to Mysore, which is about 130 kilometers, okay, so this is your Mysore, and when you draw the displacement versus time graph, this is how your displacement versus time graph looked. You took around 5 hours to cover this distance, right? When did you start? 10 a.m. p.m. Okay? And let's say you reached by 3 p.m. Okay? And when I asked you what was the average velocity of your car, you said it's very easy, 130 by 5 is the average velocity. Correct? But many of us were not able to answer what was the velocity of the car exactly at, let's say, 1 p.m. or let's say 3 hours past the journey. So let's say t is equal to 3 hours, right? Because we were struggling with the problem of how small displacement should we take in how small interval of time. That is going to tell me how fast I was traveling at that instant of time, isn't it? So in order to know what was my instantaneous velocity, now this word is very, very important. Average velocity is what? 130 by 5. That's an average, correct? And it doesn't have much, correct? What is more important to us and what is more pertinent to the physical system around us is to know the instantaneous change, correct? We need to know how instantly things are changing around us, right? We cannot now rely on average changes. That data is too old. When we are young, okay, average changes chalta hai. But when things are moving fast, we need to keep a track of instantaneous changes. Are you getting the word? So I'm looking for what is my instantaneous velocity. At which instant? At t equal to 3 hours, correct? Isn't it? Or at 1 p.m. So how do I find that out? For that I have to see how much is the displacement covered by the body. I know it's going to be too small for you to look at, so I'm just zooming in this thing and I'm just making it here. So basically you are trying to see, let's say this is the part of this curve. You're trying to see how much displacement I covered with respect to the change in the time being very, very small. As I told you, in 0.1 second, 0.01 second, even if it goes smaller than that, 0.00001 second, how much did your car travel divided by 0.0001? That is going to give you the actual instantaneous velocity, correct? So in order to find the instantaneous velocity of your car, we can say that you are actually trying to find out the change in the displacement with change in the time when the change in the time is tending towards 0. Okay? And this is something which we actually covered in the chapter of limits. So limits is a precursor to studying derivatives. Are you getting this point? So basically if you have any function, let's say y is equal to f of x, you want to know how your output y is changing when you nudge your input a slightly more. You understand nudging the input? What is the literal meaning, English meaning of nudge? A small push, a small displacement. So you want to see when you nudge your input x slightly, how your output changes.
So it's a measure of the sensitivity to nudging.
Exactly. So we are trying to see if I change my input slightly and because of that my output also changes slightly, then what is the ratio of the change of output to the change of input when my nudge is very, very small? Right? For example, if I know the price of petrol is linked to the price of tur dal. Everybody likes tur dal? No? Chana dal, moong dal, whatever dal, sambar. Okay, yes. You know, let's say if I nudge my price of petrol, then the cost of transportation will change and this will change my price of tur dal. Okay? How is the price of tur dal changing divided by the price of petrol is what we are going to study here. Are you getting this? So basically, it's the art of studying the change in the output by change in the input when the change in the input is very, very small, and this particular thing is called as dy by dx. You must be hearing of this word dy by dx every time, correct? What is dy by dx? It's actually this. Mathematically speaking, it is the ratio of the change of the output to the change in the input when the input is nudged or the change in the input is almost 0. Is this understood? Why d? D D stands for differential change, a very very small change. Correct? Please do not cancel D and D. It's linked to Y. It's an operator linked to Y.
So, it would be d of y over d of x, just to ensure it.
Yes, there are a lot of ways to express it. You can also write this term as df by dx. Many books will write it as f dash x. Many other books will write it as y1. So many ways to represent it, all mean the same thing. Now mathematically, has it sunk inside you what is dy by dx? Correct? How to find it? Let's see. I've still not answered this question. It is still unanswered. Correct? So now I'm going to actually find the derivative of a function for you and show you how do we compute dy by dx. Is that okay? Let's start with a very very basic example. Let's say I have a function x square. I'm writing it as y equal to x square. You can write it as f of x equal to x square, whatever you feel like. Okay. So what is this function doing? What is this function doing? This function is squaring whatever you put inside it. If I put 5, what will it give back to you? 5 square. 25.
So the larger the input, the more sensitive it is to that.
Exactly. So now I'm trying to see how much is going to be the ratio of the change of the output by changing the input at a given position of x. Okay? So let us say I want to find delta y by delta x. Now what is delta y? Change in y. Correct? So let's say I nudged my input to by delta x. Correct? I nudged my input by delta x. Means I just slightly increase or decrease my input with a small amount delta x. Everybody understand the meaning of delta x? Correct? Okay. Now tell me, what will be the final output? Won't it be x plus delta x whole square? Minus the initial output x square, that will be your delta y. Yes or no? Everybody understands at this stage?
Yes.
Initially your y was x square, and when your input became x plus delta x, what will your output be? Let's say x plus delta x whole square. So what will be the change in the output? Final minus initial divided by delta x will be delta x. Correct? Now I want to know what is this ratio when my delta x is tending towards 0. I'm not saying it is equal to 0. It is becoming very very small. Are you getting it? That means I'm trying to indirectly evaluate a limit problem now which says x plus delta x whole square minus x square by delta x tending to 0. Okay. Now in order to write less, I'm a lazy person, so I will write my delta x as h. Okay. Just so that I don't have to write delta and x. Okay. So it's not that I'm trying to change the concept, I'm just making my life easy. I'm using the word h for delta x. Everybody's fine with that? If anybody thinks that no, I want delta x only, I can get my delta x. No problem with delta x?
2x.
Yes. So what I'm going to do is, I'm going to evaluate the same problem. Now I'm writing it as x plus h the whole square minus x square by h, and instead of saying delta x tending to 0, now I'm saying h tending to 0. Everybody is fine with this? Is that okay? Now comes my concept of limits. How do you want to evaluate it? Do you want to expand it or evaluate it?
X square minus evaluate.
Or you can use the standard algebraic limit. Whatever you want to use, it's your call. It's your food, however you want to eat it. Let me do it by the simplest possible way, by expanding it. What is the expansion of x plus h the whole square? What is x plus h the whole square? plus h square minus x square. This minus x square. Listen to this concept very carefully, because on the basis of this example you are going to learn a lot of things. Okay, this example is going to make your concept or confuse you like hell. The call is yours. So I want absolute silence. Your attention should be totally glued to the whiteboard. Just like horse. Nothing you're saying, nothing else. Now x square cancels. Correct? Can I erase them? Can I take? Now tell me, which is the factor which is creating 0 in the top and 0 in the bottom?
Take it out.
Remember, there were 7 diseases in limits which we talked about, right? And those diseases were formally called indeterminate forms. Remember? What were the diseases? Yeah? 0 by 0, infinity by infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, 0 into infinity, and 1 to the power infinity. Okay. I have not gone into details of them, so Yash must be thinking, boss, what is going on? Don't worry. We are again going to talk about it in the limits chapter. Okay. So as of now, whatever is going on, Yash, just take it with a pinch of salt and pepper. Okay. Fine. So can I cancel out the h from the numerator and denominator? If I do that, am I left with this? Now next what I do? Method of substitution. Substitute h as 0. What is my answer?
2x.
2x. Correct. So we say derivative of x square function is 2x. Now it makes me think, derivative of x square is 2x. I didn't get a feel of it. How is 2x related to x square? Correct? Mathematically, yes, derivative of x square is 2x. But what does it mean to me geometrically?
So then,
Let me explain you that. That probably will give you a better insight. Okay? Meanwhile, I will not touch this problem because I have to still solve it. Okay? I will go on to the geometrical sense of this. Okay? Mathematically, everybody understood why derivative of x square is 2x. Okay? Now I will explain you what is the geometrical meaning of it, and then I will go on to explain you the graphical meaning of it. Correct? See, the more perspective you have about a particular concept, the better clarity you will get while solving problems. In JEE, let me tell you, or KVPY exam, they are not testing your rocket science skills. They are testing your analysis of small things. How deeply can you go with the derivatives? Right? How deeply do you take graphs? That is what they are going to talk about. Okay, so this was the mathematical meaning of finding the derivatives. So this is the mathematical example. Now I will give you, when I say mathematical example means more in terms of numbers and equations. Now I will give you a geometrical sense. Can I erase this?
Yes.
Okay. Anybody wants to copy this? Question here. Any questions so far with finding the derivative of any function? By the way, this process of evaluating the derivative is called finding derivatives through first principles. It's more primitive way of finding the derivative. It's like finding the derivative from your basic understanding of the derivative.
So,
however, in normal day-to-day solving of questions, we will not take this approach. Just like in case of limits. In normal solving of limits, we never go by taking 1.9, 1.99 and all. But for your understanding, it's very important to know this. However, you may get a question in school asking you to find the derivative of a function through first principles. Abhivay, is it understood? Please. Abhyay. What does it mean? Don't spend. Where means to spend. Where means don't spend. Can I raise this? Samir, is it clear? You don't look happy though. You're happy. If anybody is not happy, whether it's because of maths or because of some other reason, please let me know. I'll be more than happy to solve your problem. Okay. Now, geometrically speaking, Where do you see a function where x square is being seen? I see it in the area of a square. Do you see that?
Yeah.
So can I say area of a square? Let me now call it as area. So area is like the output and x is like the input. So basically if you want to find the area of a square, you need to feed the side of the square. Correct? So what does the function of area does? It squares the side and gives you the area. Correct? Now let's say I nudge my x. Right? I nudge my x by increasing it slightly on this side and slightly on this side. So do you see that this is a nudge delta x and this is a nudge delta x? All of you can see that? Hope my camera also can see that. Correct? Now I want to see, because of this nudge in the side, how much has the area of the square changed? Okay. Now, my common sense says the area of the square has changed by this rectangle area plus this rectangle area plus this square area. Isn't it? A person who knows geometry, if you ask them how much has the area changed, he'll say, boss, simple. This strip has come, and this square has come. Correct? So can I say the area of the square has changed by x into delta x plus again x into delta x plus delta x square. All of you agree with this? Anybody who disagrees? No. Now can I say, because delta x itself is a very small quantity, its square will be extremely small quantity.
So we can just
Yes,
take it out.
infinitesimal quantity. Correct? So can I say this quantity can be ignored vis-a-vis these two quantities? Right? So can I erase this? So what is x delta x plus x delta x? 2x delta x. So can I say delta A by delta x is nothing but 2x? Correct? And if I make this delta x tending to 0 and apply this limit, can I say it is nothing but dA by dx? And if I call my A as f or y, can I say I have just now found dy by dx? Are you getting this point? Look at how geometry is helping you to find derivatives. It's not like it's a modern day math, so geometry is going to be redundant for you. It's not like that. Geometry is helping you to understand what is dy by dx. So it's the change in the area by the change in x, when the change in x is very small, and my answer is getting 2x. Does it make sense to you geometrically? Yes.
This only works for this particular function.
Okay, you're gonna, yeah.
Then you can
I'll give you an example of this. Okay, I'll give you example of other function as well. I'll give you an example of sin x function. Okay.
test that. We could do 4.
Is this understood? Anybody having any doubt about understanding or relating that 2x thingy with x square thingy? Now can you relate 2x thing with x square? Are you getting it? Now I'll give you a graphical sense of it also. Let's understand it graphically. Mathematically we saw, geometrically we just now saw. Now I'll give you a graphical way of understanding what is actually 2x. What does actually mean when I say 2x is the derivative of x squared? Can I erase this?
So the speed is 6
You are Neha. Neha.
Speed is 6.
Speed is 6. This question, I will come back to it. Gaurav must be already aware of all these things. But you just refining of the same concepts. Make sense? Yes. It takes time for calculus to sink in. Even when I was studying it for the first time, I had to think very deep about it. What is actually the derivative of a function mean to me? It took me around 2 weeks to understand that. And I was blessed with a teacher who would never reveal things so easily. You'll have to keep chasing him and asking him questions. And that was actually a helpful way because he made me do the research work. Okay.
What are those things?
Can I erase this now? Ghosh Babu, clear?
This makes sense.
By the way, I am getting very few responses for QOD. What is the reason for that?
Sorry, I don't even know how to sign in.
Hey, do anything. Just show me your working.
I don't
I'm
know
more than
this.
happy that this
I
is
don't know
tried
this.
at least.
Sir, if you give me like a screenshot, I can do it. Because I can't keep. I
You don't have to keep signing in. If you sign in once, it's a
Every time it happens.
Oh, is that the problem?
That's the
So
problem.
today we have Vishal sir with us. You can just tell him your problem that I face problem while signing in. He'll let you know what to do. He's the one who's handling the tech part of it at the background. Yeah. Now, how do we mean, or what do we mean graphically when we say derivative of x square is 2x? Now, x square we already know from our graph chapter, it's a parabola. Correct? It's a parabola. Correct? Now, on this parabola, if you take a point x, correct? And let's say I take a point slightly away from this, let's say point A and point B, and I call this point, the x coordinate of this point as x plus h. Okay? Now you tell me, what will be the y coordinate of A? F of x, which is x square. What will be the y coordinate of B? F of x plus h, or in this case x plus h whole square. Everybody agrees to it, correct? Now, when I do delta y by delta x, you know what you are doing? You are finding the change in the y, that is this, by change in the x, which is this. So basically you are trying to find bm by am. Yes or no? Everybody agrees to this? What is change in the y from here to here? I would say it is x plus h the whole square minus x square. What is the change in the x? I would say the change in the x is h. Correct? Very similar to the expression that we had got for mathematical thing. Now when I say my delta x is becoming very, very small, that means I am saying limit of the function as delta x tends to 0. That means I am trying to evaluate this. Now what is the meaning of saying delta x tending to 0? Now see it. Right now in the present shape, when we did not have this limit, it was giving me the slope of this line AB, which we normally call the secant line. What is the secant line? A line which cuts the curve at 2 points. What's the tangent line? It cuts at 2 coincident points.
So you have to take it such that.
Now see what is happening. Yes, that's what I'm going to say. So right now you are getting the slope of the secant line. Correct? Now imagine I'm starting to make my s smaller. If I make my s smaller, do you realize that this point will start coming towards A? So now this will be the new position of B that we call B dash. Correct? That means now I'm trying to find the slope of A B dash. Correct?
Again and again.
Again, if I make it a little bit more smaller, let me come a little bit more nearer to this. If I come here, let's say B double dash, can I say I'm finding the slope of A B double dash? Correct? If I keep reducing this distance h and make it almost 0 but not equal to 0, can I say I will reach very close to A some point? And can I say then the slope would be almost the slope of the tangent drawn at that point? Now guys, listen to me very, very carefully. This is going to be the most important statement that you will hear from me in maths. Derivative of a function at a point x is nothing but the slope of the tangent drawn I'll write it down also. So when I say the limit h tending to 0, basically I obtain the slope of the tangent drawn